Angel asked me to talk about data protection in the cloud. I am going to talk just a little about this because I am not an expert in data protection. I am not an expert even in information technology. I'm not a computer scientist, but I am just a bioinformatician that I am suffering to some extent these problems, so I will try to share with you my experience. So I will try to share with you my experience with the biomedical big data in the projects in which I am involved that are dealing with this. So my general approach is that in the projects in which I am participating is that if we are able to integrate heterogeneous biomedical information, we will obtain a more complete view on diseases and on the therapeutics. And this is, in general, the scenario in which the projects in which I am involved are. So obviously when we talk about this ecosystem of data, so that goes from the omics data to the clinical data, including biomedical imaging, also data about how the small molecules, the drugs, interact with the proteome, and also information that is extracted from biomedical literature from the millions and millions of papers that are electronically available by text mining, for instance. We are in this ecosystem that we can call it biomedical big data, okay? So, and just to give you a couple of examples of projects in this field in which we are involved, one of them is Med Bioinformatics. I am coordinating this project. This project is also, as Pan can risk, a PhD 32 project. So we are in the same topic. So it's for me an opportunity to have this opportunity of interacting with you in the framework of this meeting. Okay, our project Med Bioinformatics is about application of bioinformatics in translational research and clinical practice, with a particular focus on oncology, another contact point with you, and neuropsychiatry. Okay, so in this project we have 5 central work packages. In some of them, for instance, work package 3, we are trying to develop tools for helping in the analysis of the genotype-phenotype relationships. In other, we are developing tools that we call in the area of systems medicine, network medicine. This is the work package that is more related with the big data, we can say. And obviously, and we have a specific work package in the field of oncology that obviously is using approaches from the other work packages. And we have a specific application work packages in which we develop case studies in the area of neuropsychiatry on one side, others in the case of CNS cancer comorbidities. Just to give you a quick view on the type of applications we are developing, for instance, in work package 3, EBI is developing a completely new version of the variant effect predictor application, the VIP application. In work package 4, for instance, there is one of the applications that is being developed that is related with the topic of today's roundtable, that is the disease trajectory comorbidity browser. This is an application that is being developed by the group of Søren Brunek in Denmark. And for instance, a starting point of this application is this work that they did about the analysis of temporal disease trajectories from the Danish population. So they analyzed the Danish population for genetic disease trajectories, and now they are implementing this in an application in which everybody can navigate exploring these disease trajectories. Obviously, to have this type of applications imply the analysis of millions of clinical records, and obviously the ethical or principles and so on are behind this. In work package 4, we are also developing a disease biomarker browser. This means the possibility, for instance, in the framework of this work package, for instance, we are further developing DigiNet, this comprehensive platform that integrates information on human diseases and associated genes and variants. CGNet is a derived application from DigiNet in which we concentrate in the psychiatric area, but all the associations that have been extracted by text mining are curated by experts in the field. In the work package 5, for instance, the group of Nuria Lopez-Vigas, they are developing the cancer genome interpreter. This implies, obviously, the introduction into the system of data of individual patients for making predictions about the prognostic and also therapeutic approximations. We have in work package 5 also the participation of the Finnish FIMP, the Institute for Personalized Medicine in Finland, and they are developing a pipeline in which they try to propose the best drug combinations in oncology on the basis of using evidence, scientific evidence on one side, and also information from specific patients on the other side. Obviously, they have also to take into account the ethical aspects when they implement this application in practice. And these were just some flashes about the type of applications we develop in Made by Informatics. This is another project in which we are involved that is related with the topic we are discussing today, is this EMIF project. EMIF is another IMI project, is an IMI project, European Medical Information Framework. This is a project about the reuse of clinical data in research. This project tries to develop a framework, a European framework, in which data that is already available can be reused for research. Okay? This is a huge project with the participation of about 60 partners, 60 million euro of budget, and so on. And the project has 3 parts. One is the development of a framework for evaluating, enhancing, and providing access to human health data across Europe. The objective is to make available more than 40 million electronic records and other type of clinical records for research. And then there are 2 sub-projects that make use of this infrastructure. One about obesity, metabolic complications in obesity, and another about Alzheimer's disease. So the idea of this project is to use it in discovery, for instance, in biomarker discovery, in drug development, for instance, by facilitating the design of clinical trials and analyze its feasibility, and also facilitate the patient recruitment and so on. And after the drug launching into the market, for instance, this application can be very useful for making a follow-up of the efficiency and safety of the drugs. For instance, this particular part, the analysis of the clinical trial design and feasibility analysis has been implemented in a particular application that is called Insight Champion Program, that will expose not individual data, but the particular figures of patients with particular characteristics to an organization, normally a pharmaceutical company, trying to implement a particular clinical trial. Okay, so in the development of this project, for instance, it has been already developed a catalog. A catalog is like a data shop window in which interested parties can see what are the data sources and the characteristics of these data sources that are available. Also, we have also developed software for data extraction, harmonization, and aggregation for making possible the joint analysis of all this data. And we also been working in the implementation of the OMOP data model for making possible the data harmonization. And in particular, in the area of biomarker discovery, the project has developed a dedicated Transmar implementation for the analysis of data in biomarker discovery. Okay, so with my previous flash in Made Bioinformatics and eMyth, I tried to give you a view on my experience in projects in which we have these type of problems of dealing with huge amounts of clinical data. So when we talk about this problem of the private health data, what are the challenges? There are, I think, three types of challenges. There are the legal challenges that the previous speakers have put on the table very well. What is the framework of this? I will try to add my modest contributions to this. We have also, and very importantly, cultural issues. So at the end of the day, sometimes it's more a problem of the perception of people than a problem of the legal framework or the technological framework. So in fact, for instance, sometimes in particular places in Catalonia, we had an example of this last years. There is a particular sensitivization of people about how my data will be used or will be reused, or so. But it's a particular perception, cultural perception, because maybe the same people that is so concerned about this is not concerned about how, for instance, supermarkets will use their data about the ways they do the shopping, or, for instance, they are not worried about the fact that, for instance, Google is reusing all the searches they do about health, their health status. So we have to be aware that every second there are about 40,000 searches in Google. Of these 40,000 searches in Google, 2,000 every second are on health-related issues. So, and this information is stored, this big data is stored by Google, is analyzed, and is connected with other actions we do at the same time. So, and we are not particularly concerned about this, but we are very concerned if our clinical record will be used or not for research. So there is a cultural issue we have to be aware and to manage and also to make pedagogy to the society about this. Then we have the technical solutions, and then we enter into the cloud. Cloud, to what extent it's good or bad or has problems. And sometimes we have some confusion with another concept, another technical concept that is the VPN, the virtual private network. Is obviously not the same, that cloud, but to some extent is another way of sharing, another way of working together that we have to keep in mind. Okay, so when we talk about privacy in healthcare data management, there are two scenarios that are completely different and would have to be managed in different ways. So one is the data that result from clinical studies. Okay, so this is very important, very usual. In this case, the way of managing it in a way that has no legal complications is to work well, and you explained it very well in the first presentation, on the basis of the informed consent process. You do a good informed consent, and in principle, everything is under control from the legal point of view. Every time we have more in this big data scenario, there is an intention of reuse of routine clinical data for research. And this is a completely different scenario in which we are facing additional problems from the legal point of view and from the feasibility point of view. From the legal point of view, we have been explained very well in the previous presentations. We have an heterogeneous international legal framework and probably will continue having an heterogeneous legal framework because the different countries, you explained it very well, have the right of introducing additional requests and so on. So we have an unclear, a gray Spanish legal framework, depends on the way you read the laws or what law are you reading, the situation is different regarding this particular point here. We should be aware that there is an practical feasibility of the opt-in option for populational databases. So if we try to reproduce the study done in Denmark with the clinical or the disease trajectories in Spain or in Catalonia or in Galicia, it's impossible to do it on the basis of informed consent process. It's absolutely impossible. For many reasons that all of you are aware. But even if we decide, okay, we will make an effort, we will send letters to all the population, we will make phone calls to all the population and so on. At the end of the day, only a part of the population, for different feasibility, will maybe a 20%, a 30%, will be incorporated into the study. We can say, okay, at the end of the day, we have, instead of 40 millions, we have only 4 millions or 8 millions, is fantastic. No, but then, for many of the purposes, this will be not useful because these 8 millions will be completely biased, are not representative of the 40 million. This is a point to have in mind. Okay, what are the feasible privacy protection measures in this type of cases? Obviously, first of all, implementing some kind of opt-out provision, so the right of people, as you explained it very well, of revoking the use of his or her data, anonymization, of course, approval and follow-up by the clinical research ethics committees and so on, and obviously publication, dissemination of only aggregated analysis, so not individual cases, but aggregated analysis. Probably there are others, but we have to work, I think, and to promote this type of measures and to try to convince the population that this option is not possible. It's not possible for if we want to produce interesting science in this field. Okay, technical measures. Only three slides I already have. Okay, so what is the cloud computing? I think was already presented. These are the definitions of the National Institute of Standards and Technology of the US. Is the reference for this. Okay, what is cloud computing? Cloud computing is a model for enabling ubiquitous, convenient, on-demand networks access to a shared pool of configurable computing resources. Okay, this is a technical definition, but I think we have to center in these 5 essential characteristics. First, that is on-demand self-service. A consumer can unilaterally provision computing capabilities as needed automatically without requiring human interaction with each service provider. So you can make the configuration of the service you need without having a personal dialogue with different providers of services. Broad network access, so this means that the capabilities are available over the network and accessed through standard mechanisms. We can access using a mobile phone or a tablet or a laptop or a workstation from any of these standard mechanisms. Resource pooling, There is a sense of location independent in that the customer generally has no control or knowledge over the exact location of the provider resources. This is very important from the legal point of view. It was already stressed, but it's possible in a cloud computing facility to establish a specific restriction in terms of location, for instance, country, state, or data center. So this is possible, technically possible, and is included in the definition. And this may be a solution for some legal problems. Rapid elasticity. The capabilities asked by the consumer often appear to be unlimited and can be appropriate at any time, in any quantity, at any time. So in any moment you need more space or more computing power, you can immediately get it without apparent limit. Measure service. The resource uses can be monitored, controlled, and reported, providing transparency for both the provider and the consumer of the utilized service. Okay, these are the main characteristics of a cloud service. As was already explained, that there are different deployment models, private cloud and public cloud. In general, we think about public cloud, but it's possible also to have private clouds in which the cloud infrastructure is provisioned for exclusive use by a single organization, compromising multiple consumers. For instance, a big company located in many places of the world. Even it's possible to create a cloud inside the premises of a particular organization. So, for instance, I don't know, in Basel, Novartis can set up a cloud computing service that is internal in the company, not external. Okay, so finally, my final contribution in terms of concepts for discussion. What is a virtual private network? A virtual private network extends a private network across a public network such as internet. So it's a way in which, for instance, an organization, and this is typical in banking, in big multinational companies, and so on, they establish a private network that the connection between the different pieces of this network are done through internet by creating some kinds of tunnels, technological tunnels, that make data goes from one place to another without being exposed to possible attacks or possible hackers or anything like this. Even individual users can, from their laptops or can access to all this network at any moment from any place. So this is not an alternative to cloud, but is another way of working that we have to keep in mind as a way of having different parties working together around the world without compromising or without exposing the data. In fact, banks, big pharmas, and many other corporations are using virtual private networks for having everybody connected, everybody working together without exposing secrecy to others. Okay, that's all on my side. So if you are interested in knowing more what are we doing in this respect, please visit us.